Okay, 4.7 applied. Optimization problems. So in this section, we do minimize production optimization means production or minimize revenue. Okay. So let me draw because I want to save the space. So here, one side is the rock wall, right? Okay, and we want to make the garden. Then let's make the variable here, which is, let me using same variable, x, y here. Okay, now we want to make garden. So what is area? Do you remember area, a formula of area? Area, which is the one side times other side, right? That is
base times height.
yeah, x. So in this case, x times y, right? Good. Then we have a wire is given, right? So how much was it? Where is it? I cannot, yeah. Given 100 feet of wire fencing, right? This will be, we consider perimeter, right? Okay. Okay, and say that maximum area, right? Then what's the perimeter? The formula of perimeter. We add every side, right? Correct? Okay, so we have x plus y in this case, right? So in general, we write down 2L plus 2W, right? So let me write that in general, like 2L plus 2W. But in this case, we have a 2x plus only 1y, right? Okay, now this is a perimeter, so this is 100. Okay, so let me erase this perimeter. Okay, now we're gonna solve for y. Then y equal to what do you get? We get 100 minus 2x, right? Okay, now we're gonna substitute into y equal to there. Okay, so we're gonna make this area in terms of a function x. So I'm gonna write down this a of x, the x times 100 minus 2x. Okay, and we distribute, we get 100x minus 2x squared. All right, so we create a function, right? Now, we want to find the domain. Okay, so we call this is a feasible domain. Let me write down. And I'm scared he's picking on my spelling domain. Since we talk about the length, right? So x must be greater than 0, right? And also y is greater than 0, right? Then let's talk about 100 minus 2x. Solve for x, what do you get? X X. Okay, x equal to 50, all right? Then domain will be between 0 to 50, okay? Because it must be x is greater than 0. We don't want the just nothing there, right? And then the maximum will be 50. If we over 50, then we will get the negative, right? Okay. All right. Then from, I don't want to write down, okay, listen. From previous theorem, we have extreme value theorem, okay? Then the function is continuous and bounded and closed interval, right? Then there exists absolute maximum and absolute minimum, right? So we're gonna use that theorem to find the maximum area, okay? Then what we have to do, we're gonna find the critical points, and then we're gonna evaluate at the function. And also we're gonna take out the endpoints and we evaluate into the function as well. Then we look for absolute maximum, okay? Here. So we say that x is greater than 0, but we're gonna say domain will be between 0 to 50, okay? Because we are using extreme value theorem. It must be closed, all right? Okay. So now, can you please derivative this one? What do you get? For x minus 100. Good. Now, can we find the set x equal to, this one equal to 0, the x equal to critical points, right?
I think it would be opposite. I think it would be negative 4x plus 100.
Okay, thank you.
Mm-hmm.
So we get 100 minus 4x, right? Okay, then what's the x? Do it. Don't smile. Just do it.
25.
25. Thank you. Okay. Then we're gonna just substitute. Easy. I need your help. So we substitute into the function. So 25. So the function is 100. And then 25 minus 2, 25 squared. Can you please calculate? So we know it's 0, 50. Can you please calculate this one? What do you get this one? A over 25.
It's negative 1150, but how can it be negative?
We cannot have a negative.
Oh, it's 50. It's 53. Never mind. No,
Oh.
Is it 25 or 50? No, for 20.
We're gonna do 25, then we're gonna do 52 because 25 is the critical point, 50 is the end point. Okay, we have to do both. So basically,
Okay.
we have to do 3 things here.
Oh no, I just did it wrong. I did the math wrong. Sorry, it is not negative. It's positive 1250.
So someone give it to me. A over 25, then $4.50. What about A over 50? Zero. Do we get the A over 25? 125, yes. Okay, so then we get this is the absolute maximum. Okay. So when x equal to 25, right? Then y equal to 100 minus 2x. Two times 25. Can you please calculate 100 times 2 times of 25? Let me see the book a little bit slower. So it's a 50, okay? So unit is a feet. So when x equal to 25, y equal to 50, and then they can make a maximum area, which is 1250 feet squared, right? It's okay? Let me erase this one.
So really quick question at the end, then go back and plug the x and y values that we found into the area to find the maximum area. So would we do area equals 25 times 50? Is that the final answer for the maximum area? Or no?
Yeah, so 25 times 50, what do you get?
I don't want to do it for my head, so I'll just put it in the calculator. 1250. Oh, it's the same as the other
1250, yes.
before.
So
Oh,
we
okay.
found here, right?
Yeah. Yeah.
Then
So
this
it's
one is the absolute
around
maximum
that.
gives us that, right?
Okay.
Then we have x equal to 25. We are using that. Okay.
That makes sense. Thank you.
You're welcome. Let me erase this one. Okay, so let us check that the volume of a box. What do you get? One side, other side, height, right? So that is length times width times the height. All right. Now, we need to cut the edge, the corner, and then make a box, right? So if you think about your working at UPS, okay? Then you do this job, then you get promoted, all right? So maximize the volume with this material. Okay. What's the given information? We're gonna make the volume as a function in terms of x, okay? Then let's say this is a length, let's say, okay? Because in math, longest side is length, shortest size is width, okay? Then this one, I'm not going to drawing. This is x. This is x. Hey, not good. All right, so then can you imagine? We have a 24 there, right? We cut, right? There is a 24 minus x, right? For 2 of x. Can you see that? I'm talking about this one, right? It's okay. So this will be 24 minus 2x because we have to cut the corner, right? The length, longest one as well. There is a 36, like that. Then we're gonna cut here, right? So there's 2 of them. So 36 minus 2x. Is it clear? Now we are looking at the height here, okay? Height. Then the height we called x, okay? Now let us find the domain, feasible domain, okay? X must be greater than 0, right? But then, what about the maximum? How about 36 minus 2x equal to set 0, okay? Then what's the x will be? Can anyone use calculator to for us? It's 18, thank you. Okay, look, if we plug in 18, 24 minus 2x in the width, right? We get the minus, negative. So we don't want that. Okay, How about 24 minus 2x? Set equal to 0. Then what's the x will be?
12.
12. So this is okay in the width. This is okay with the length. We don't get the negative, right? Okay. So let us pick the 0 and 12 as endpoint here. And then, as I said before, like an extreme value theorem, we have to have closed, right? Bounded. So we're gonna make a close. We'll do this number. Okay. Now we're gonna find critical point. That's it. Then we substitute and then we evaluate, right? So what do let us simplify this one. So let's do this one. I'm gonna use the book for x cubed minus 120x squared plus 864x. Okay. Now, in order to find the critical point, right? What do you get? We need to do that, right? Derivative? Oh.
12 squared minus 24x plus 864.
Okay, thank you. So looks like it's wasn't squared, so she said it's 12x squared minus 210x plus 864. Okay, now let's set up. This is equal to 0. Can you please do that? Now, can you please factor out? Oh, this one cannot factor out. Quadratic formula. Oh my goodness. X equal to minus b, right? So my
Is it 240x? Not 240x? Not 210.
240x. Thank you so much. I fixed that. 240. But 20 is okay, right? Good. Thank you very much. 240. All right. So quadratic formula, negative b. So we have a positive b plus minus b squared, which is 40, right? And minus 4 times 8 times c all over 2a. Okay. Now we have inside 112 over 2. Then we simplify 4 square root of 7 over 2. Then simplify more. Then we get the 2 goes to 20 10 times and 2 there. So 10 plus minus 2 like that. Okay. All right. Then just evaluate the critical point and domain endpoint into the function. Okay. All right. Then let us do this one. Let me erase on the top. There's no space. Okay, I need your help. Can you please do that for us? V of 10 minus 2 square root of 7. And V of 0, V of 12. Okay? Where? Yes, we did that. So that's why 40, isn't it? Four cube minus 120 squared plus 864. Oh, sorry. It's negative? Yeah, sorry about that. So 400, did I make a mistake somewhere again? And then negative, where negative? Okay, so square the positive, yes. Okay. So it's a positive number because squared. All right. Okay, can you please calculate? Okay, we don't use ten plus 2 square root of 7. Okay, because this is over, how much this one? This is over 15. This is value is 15.29, which is over beyond domain. Can you see that? Okay. All right, so what do you get? V of 10 minus 2 square root of 7. Too much work, huh? So this one, let's see. This is a 1,825. Okay. And V over 0. What do you get V over 0? What do you get? Do you get V over 0?
0.
It's 0. How about 12? 4, 12 to the third power, 120, 12 to the second power, plus 864 to 12 to the, yeah, just 12. Can you please calculate that? So we're gonna find the absolute maximum, right? Because they want maximize the volume.
It's 29376.
Okay?
It's 29,376.
76.
Mm-hmm.
This is a more bigger.
Oh, I think, never mind. No, I just did it wrong. Sorry. No.
Yeah, this is should be smaller, right?
It's 19,872.
Still,
Maybe I just entered something wrong. I don't know.
what zero? Is it zero? This one zero as well? Tell me, is it zero? Okay. All right. So how about other people? You got zero too? Okay, then we do maximize the volume when this is absolute maximum. Okay. Good. This is zero. Okay. So this is X. So this is the X value, right? When X equal to that. So X equal to height in this case. So height was the 10 minus 2 square root of 7. And then width, which is 24 minus 2 times. Can you please calculate? And then length, which is 36 minus 2 times of 10 minus 2 square root of 7. Okay. Then we get the maximizer volume there. What do you get? Ten minus 2 square root of 7. $4.7. Thank you. 7.1. And 24 minus 2 times of 10 minus 2 times of 7. So maybe we can do 4.71, right? Let me do 36 minus 2 times 4 times 7. Okay. So I got 26.50 for this one. How about second one with 14.15? Okay, thank you very much for doing this. All right, good job. Where is the one? Okay, so this is a very interesting problem, right? So they have a linear function, which is n for the number of cars, the rent per day, okay? So they make a function of P means the price, dollars. So they make N over P equal to 1000 minus 5P. Okay, and then in the beginning, they mention about between 50 to 200. Okay, so $50, right? $200, right? So let us do this one. All right. The revenue, the formula, we don't know, right? But it's very understandable. So let me write down for you. Revenue is N times P. So N in this case, number of cars rented per day times then price charged per car per day, right? Makes sense, right? Logic, okay? And they can make money, right? Revenue is number of cars rented per day times price charged per car per day, right? So in short, we said R equal to N times P, okay? Now, we have the function is here, N, okay? So we plug in there. So what do you get? We have 1000 minus 5p times p, okay? And we do distribute, then we have, this will be 1000 p, hold on 1 second, this one. P minus 5p squared, right? Okay, now we're gonna create this one as a function of p, which is dollars, right? Price dollar, okay? Now, in this case, they already give us the feasible domain, the dollars between 50 to 200. So there will be domain. Okay, now we just find critical point and then we evaluate, right? That's it. So what is R prime over P? What do you get? With derivative? So 1000 minus 10p, good. Now we set this one equal to 0. Find the p. So what do you get? P equal to what? Thank you. P equal to 100. Now we're gonna plug in, we're gonna substitute into the function. So R of 100. Can I just erase a little bit here on the top? I just need a little bit. Okay, can you please calculate for us? So R of how much? 100, which is 1000, P 100, minus 500 squared. Okay, and then can you please calculate? Ooh, thank you. And 50, and can you please calculate the 200? Thank you so much. Okay, so what do you get? 50,000, sorry, squared. So it's a 50,000. How about the when p equal to 50? What do you get? Hmm?
37,500.
Good, thank you so much. And 200?
It's 0.
0. So this is the absolute maximum. Okay, so when the rental car company sells the price of $100 per day, then they make more money in this case, right? So the price $100, the company maximize. Hey, next. Next, next, minus revenue. Okay, let me just stop here. All right. I'm gonna erase this one.